Hi, welcome to clickmyproject.com. Now I'm going to explain a complete demo of my project. Title is an ontology-based text mining method to cluster proposal for research project selections. In this project, I'm going to cluster in the project proposals based on the ontology. In existing system, they did it manually, and also they use only normal text mining method. Thereby, they lost an accuracy of project proposal selections. So, in our proposed systems, we use the ontology-based text mining. So, we can't lose our accuracy. And also, using this method, our computational times also reduce. This is the flow of my project. For this project, at first we need to load the last 5 years funded projects. After loading the funded projects, we need to choose the keywords and their frequency. After calculating the frequency, we need to construct the research ontology. Based on this research ontology, our new proposal can be classified. After constructing the research ontology, we can import our new proposals. Our new proposals can be clustered into the groups. So based on the SOM algorithm, after clustering it, if it is the group is too large, means we can regrouping it. If the regrouping can be done based on the affiliations. If there is no, means it will be assigned to the reviewers. Now I am going to execute a complete demo of my project. For this project, first of all, I need to run a feature.java. After getting the frame, we need to construct the scientific research areas. In our project, we can construct the 4 scientific areas. First, we can get the computing and get the discipline code, and we can get the funded keywords based on the last 5 years projects. And these are all the funded keywords for this research area. First of all, we need to select the one keywords and count their frequency. Likewise, we can get the frequency for all the keywords. And then cost, then data forward. We are finding these frequency for these areas, and after that I want to selecting the another research areas and get the discipline code for these research areas and get the funded keywords for selected research areas. These are the keywords for the research areas, energy and environmental, and also you can calculate the frequency for each keywords in the research areas, selecting these keywords and click frequency. So likewise, one by one we need to calculate the frequency for each keywords in that field. Then another research area and get a discipline code and get a keywords and calculating the frequency. Another research and discipline code and get the responded keywords and calculating the frequency. After calculating all the research areas frequencies, we need to construct the research ontologies. For constructing, you need to click constructing. In this field also you need to select the research area for construction. First of all, I need to select constructing a research ontology for computing. Then the structure is the SR denotes as a scientific research areas. These are all the keywords. The keywords can be assigned based on their frequency. Likewise, we can select any other research areas. After selecting the structure, we need to select the repaint and then click structures. And these are all the ontology for research ontology structure for information science research areas. And then if you want to click the new proposals, in this frame we can import our new proposals files. Our new proposals files can be classified, that means clustered based on their last 5 years funded projects, keywords, frequency. And then here itself we can selecting the discipline areas. Here also we can select the 4 discipline areas, and also the funded keywords, the keywords that are displayed based on the research areas. And then we can import our new proposal. Click import. And then we are going to select our data set, that means new proposal file. Now I am saying this as a proposed.txt file as our proposed file. After selecting these proposals, we need to click a sorting algorithm. We can apply the sorting algorithm for each keywords in our discipline areas. Likewise, the resource, distributed, after assigning the sorting algorithm for each keywords in the research areas, we need to click a clustering. In this clustering phase, we can cluster our research document. At first, we can load our file. The sort.txt file will contain the shortest order of our proposed.txt file. And then click a document pre-processing. Then in these pre-processing steps, we can perform a removing for stop words. After removing all the stop words, we can display these words. These are all the words can be displayed perform after pre-processing. And then we need to further reduction it. For it, we need to click further reductions. Now the text documents will be further pre-processing. And then we need to encoding it. For clicking encoding. In this frame, our text documents will be encoded. First, we need to choose our research areas. So based on these research areas, the keywords will be selected. So based on this keywords area, we need to calculate the term frequency, inverse document frequency encoding. Likewise, we can calculate the term frequency, inverse document frequency for all the keywords in this research areas. Then the next research areas, based on the features are selected, and then we need to calculate the term frequency for this selected research areas keywords. And then the information science. Now the information science features are selected. We need to calculate the term frequency values. And security term frequencies values. After finding the term frequency values, we can select our feature vectors. These are all the feature vectors for security research areas. And then you can select the computing. We can click the computing research areas feature vectors. Now we can reduce the feature vectors. For reductions, you need to click the reductions. In this frame, we can reduce the feature selections. But first we need to select our research areas and then the funded keywords. So now these are all the keywords can be displayed. After further feature reductions can be performed. Now we can calculate the keywords for semantic value. Now the semantic value can be calculated for selected keywords. Now our keywords can be classified based on their semantic meaning. Likewise, the other words, we can classify the each words in a research areas. Information science, and these are all the selected funded keywords, and calculate the semantic meaning for classifying. Then research, and then last security research areas. These are the selected keywords for security research areas, and calculate the semantic indexing values for classify the proposals. After calculating the semantic values, we need to click the latent semantic indexings. These are the selected features vectors, and these are the semantic indexing values for selected research areas. Then we want to clustering it. So we need to click vector clustering. This is the frame we can perform our text or vector clustering. First we select the discipline area, and then feature vectors. These are the selected features, and this is our proposed file. And the selected features can be clustered based on their similarities. The similarities can be calculated by using the similarity calculations jar file, and this home implementation can be used to clustering the same similarities value. Likewise, you can select another discipline areas, and the discipline areas corresponding when the keywords can be loaded, and we can clustering the keywords using the SOM algorithm. Likewise, the information domain, and these are all the selected funded keywords, and implement the SOM implementation for clustering. After clustering, for checking its size, we need to click regrouping. In this frame, at first we need to get the size of our proposals. If the size is too large in the sense, we need to rearrange it. Now the reorder can be based on affiliation, and then group it. Now the balancing the searches are grouped, and then find out the performance. These are all the frequency for each keywords in our research areas, and also it denotes as the funded keywords frequency. That's all. Thank you for watching this video.